how do you find the curve of best fit? Well, I'm not going to show you that, but I am going to show you how to find a curve that fits 3 points. And that curve will be a parabola. It says find a quadratic function. In this example, it says find a quadratic function that fits the given points. We have the point 1, 4, negative 2, 16, and negative 1, 6. So you want to find, okay, you're kind of working in a backwards direction here. You want to find a parabola, essentially, that goes through those 3 points. That's what it means to find a quadratic function that fits the given points. Its graph should go through those points. So here's how you do it. A generic quadratic function looks like this. F of x equals ax squared plus bx plus c. But another way to write that would be, you could think of f of x as y, and you could put that on the right side instead and write it as ax squared plus bx plus c equals y. So in order to solve this problem, realize you just need to find a, b, and c, such that when you graph the parabola, it'll go through those 3 points. And in order to solve it, you have to remember what it means to say like 1, 4 is on the parabola. When you say 1, 4 is on the parabola, that means if you plugged in its x-coordinate and its y-coordinate into the parabola's equation, into the quadratic function, you'd get a true statement. And that's the key to solving this problem. Because that means if you plug in 1 for x, so you plug in 1 for x, you'd get a times 1 squared plus b times 1 plus c. You'd better get 4 for y. That's what it means for the point to be on the graph, by definition. And you've created an equation with a, b, and c in it. In fact, the equation, if you simplify it, is just a plus b plus c equals 4. Now, if you do that twice more with the other 2 points, you got yourself a system of 3 equations, 3 unknowns, which we know how to solve. And it's actually really good review for the final, so let's do it. Okay, help me out here, you guys. Can you plug in these 2 values and create an equation like I just did? What are you plugging in for x in that second point? So you're going to plug it in right here, in for x. What do you plug, and y? What are you plugging in for x? So negative 2, and then out pops y, 16. So you get a times negative 2 squared. Put parentheses around the negative 2 and square it. You're plugging in negative 2 for x, plus b times negative 2, plus c equals 16. What happens if you simplify that? What's negative 2 squared? 4, so 4 times a times 4 is the same as 4 times a, right? Plus b times negative 2, what's a better way to write that? Just minus 2b, and then plus c equals 16. So there's two of your equations, okay. And then plug in the third point. I went up too far. Plug in the third point, negative 1 for x, 6 for y. What do you get? Well, a times negative 1 squared, that'll just be 1, won't it? So a times 1 plus b times negative 1 plus c equals what? The 6. Everybody see what we're doing? Plugging in x and y into this equation. Everybody good? Okay, what does that simplify to be? A minus b plus c, good, equals 6. There you go. So the idea then, you guys, is to solve this system of equations for a, b, and c. Then you can plug back into the quadratic function to get your quadratic function. Does that make sense? Let's remind you how to solve a system of 3 equations, 3 unknowns. Like I said, this is great review for the final. Okay, take a look. Which variable would you like to eliminate? Well, it's not really a variable, but which unknown would you like to eliminate? I like that idea because I could take the first, so there's three equations, right? There's equation 1, equation 2, equation 3. Couldn't I take 1 and 3 and just add them together and eliminate b? So if I take equation 1 plus equation 3, what do I get? So I'm not going to write them right next to each other. You just have to kind of ignore the middle equation for now. In fact, I'll put a line through it, and then I'll erase the line in a second. Just add the first and the third. What do you get? A plus A, 2A. B plus negative B, by design, gone. C plus C, and 4 plus 6, 10. Okay. So, what could I divide through by to make this equation even a little easier? 2. What do you get if you divide by 2? A plus C equals 5. Okay. Now we need to remember what the technique is. You take the equation you haven't touched yet and eliminate the same unknown. So which equation haven't we touched yet? The second one. Now, I could take either the first or the third and eliminate that b value, right? But it's really important you eliminate the same unknown. Which equation makes sense to use here other than equation 2? The first one, because it has a positive built in, and the second one has a negative built in. And so all we have to do to the first one is what? Yeah, so take the equation 1, multiply by 2, and what do you get? And by the way, we're ultimately going to add that 2 times equation 1 to equation 2 to eliminate the b's. But let's go ahead and show the work on this one. What's 2 times equation 1? Just double everything. What do you get? And then we're going to add that to equation 2. 4a minus 2b plus c is equal to 16. Add them together, what do you get? 6a, b is gone, plus 3c is equal to 24. Is there any way you can make your life easier on this one? What could you divide through by on this one? Yeah, what does that give you? There you go. So remember, the idea is now we've got 2 equations, 2 unknowns. So we've got this guy and we've got this guy. Let's write them right next to each other. 2a plus c equals 8 and a plus c equals 5. The idea is now to solve that reduced system. What's a good way to do that? How about eliminate a variable? Which one could you eliminate? Yeah, just subtract the bottom one from the top. Or multiply through by a -1 and add. That gives you, just because I'm running low on time, a gone equals 3. 8 plus a -5. And then which variable do I get next? C. And I would plug that in, that 3 in that we just got for a. Ignore the negatives now. A plus c equals 5, so 3 plus c equals 5. What does that mean for c? C equals 2. And what else do we need? B. Which equation would be easiest to use to get it? Yeah, a plus b plus c equals 4. Plug it in. Plug in what you know, and then find what you don't know. Okay, a plus b, okay, that would be 3 is a, plus b we don't know, plus c is 2 equals the 4 on the right side. Does everybody see that? A plus b plus c equals 4. And so we get b plus 5 is equal to 4, or b equals -1 if you subtract 5 from both sides. Okay, so we've got B, we've got A, we've got C, but we're not done. We have to plug it in, right? Remember, the quadratic equation has the form f of x equals ax squared plus bx plus c. And so now if we want our quadratic equation to go through those 3 points, just plug in the a, b, and c that you found, and that will be the right quadratic function, really. So if I plug those in, I get f of x is equal to what? 3x squared minus bx, which is minus 1, right? Just so minus x. And then c is 2, so plus 2. So 3x squared minus x plus 2. Everybody buy that? Okay. So you could test it, by the way. You could plug in the x values of those points and make sure you get the appropriate y values. But that's it.